All right, we're going to continue with the same standard that we started with yesterday, 8G1, lines taken to lines, segments taken to segments, angles taken to angles, and parallel lines are taken to parallel lines. We'll learn kind of more about what that means today. Our objective for this lesson is that by the end of the lesson, you'll be able to explain that a translation, we kind of talked about this yesterday, a translation maps, we talked about that yesterday as well, lines to lines, rays to rays, segments to segments, and angles to angles. Okay? You'll learn that translations preserve the lengths of segments and degrees of angles. So that just means they're going to stay the same. All right? You'll know you're successful when you can perform translations along a vector. So you're going to learn what this word vector means as well today. Okay? Let's go ahead and get started. All right, just to build some background, kind of bringing you back to what we talked about yesterday. In the next few lessons, we're going to learn about 3 kinds of simple rigid motions. Okay? And like I told you yesterday, there is a 4th motion, but it's not a simple rigid motion. Okay? Because it changes the actual shape. So these are called translations, reflections, and rotations. Again, they are the basic rigid motions. We call them basic because basically it's a super simple movement, right? We're either sliding it, turning it, or flipping it. And the following, they're going to explain how to map this shape right here onto this shape using those rigid motions. And the first one we're going to focus on today is just sliding, which we call translating. And we usually translate along a given vector, which is just a line so that it stays straight. So on a coordinate grid, our vector is just like our coordinate plane. But if we don't have a coordinate grid, we use these things called vectors to move our objects. So maybe you would make a vector that goes from here to here. And then you just slide it at that angle until it goes up. Okay, so that's our background. Let's go ahead and move into the next slide. All right, so more about the vector. So the vector is a line segment. So here's vectors right here. And basically it tells you what direction you're going to slide your shape. So for this first one right here, AB, you can see the arrow is pointed that way. So you would be sliding your shape from A to B. For the second one, it is pointed this way. So you would be sliding from B to A. Okay, so the direction is given by one of the endpoints. It has an arrow. All right. The length of a vector is basically just like how long it is, and that's how long you're going to be sliding the shape or moving the shape. And then we write vectors, we name them. So we name them from where they start to where they're going. So this one right here would be A, B, and then we put on top of it a little line with the arrow showing which direction it's going. All right. For this one, we're starting at B and we're going to A. You can see that's the way it's moving. So this one will be called B, A. And this is the way that it's going. All right. So that's a few little just pieces of information, vocabulary about vectors. Again, if we were going to be moving this shape, we would have a vector probably right here. And if we're moving from this side to this side, let's call this C, let's call this D. We would say, okay, we slid this or we translated this along vector CD with the arrow pointing towards D because that's the direction that it's sliding. Okay, moving on. All right, for exercise 1, it says draw at least 3 different vectors and show what a translation of the plane along each vector looks like. So I'm going to start with this one right here. And I'm going to call this vector MN. Okay? And so I'm just going to see how I would move one shape along that vector. So basically what I'm going to do is I'm going to start with a point. I'm going to do this crescent and another point. And I'm going to move it the exact angle of this vector, right? It's going to be like that angle and the exact length. So obviously this is not precise because I don't have a coordinate grid or a measuring tool that I'm using, but it would be like this. That seems about right. And this, that seems about right. And so my new points will be here and here. And then I could draw that shape. It is not perfect at all. It's actually terrible. But this would be my new shape And we would call this R prime because my first shape right here is R, so this would be R prime right here. I tried to make it look better. It just looks like terrible banana. Okay, so I want you to draw your own vector anywhere on this page, and then choose one of the shapes to move as well. Okay, and then hopefully you get the gist of it. While you are doing that, I'm going to draw one as well. I'm just going to draw one right here. I'm going to call this ST. And if I'm moving this shape along ST, sorry, you can hear my daughter hiccuping in the back. I'm going to say this is probably like that long, that long, that long, and that long. So my new shape, I'm going to say it would be probably right here if I moved along that vector. And again, this would be called V prime. I forgot to write the name of my other one earlier, R prime. But basically, I just want you to do it to one of these shapes, draw a vector anywhere. And that vector tells you how long you're moving it. So maybe you draw a vector that's like, let's go this way, that's like super long. And you would take these points and you would move them exactly that length. Put them there and just kind of trace that shape. Okay. Again, this is just meant to be a practice so that you're kind of understanding how this works. It's not completely accurate for right now. We're just getting the gist of it, okay? Let's go ahead and move on. All right, moving into exercise 2. It says the diagram below shows figures and their images under a translation along HI, segment HI. So if we look, here is segment HI. Shows that you start at H and you move down to I. So that's how long these things are moving, and that's the direction that they're moving in. It says use the original figures and the translated images to fill in missing labels for points and measures. Okay? So for example, if I were starting with this shape right here, and I have these 3 points, A, B, and C, then I know that once this translated along this vector, it maps to this shape down here. And so, if this point was A, that means this point that it matches is going to be called A prime. Just A with a little dash. Okay? And you can either, use your highlighter and show that this would be B and this would be C prime, B prime and C prime. Or you can just kind of intuitively know. The last thing I want you to know is that this angle right here, I'll highlight it in red, this angle is 31 degrees. That means this is also 31 degrees, and we're going to actually add that in there because we know that information. We want to add as much as we can. And so we've done one. All right. There are other figures here. We have this one right here. This one maps to this one down here. You can see that these 2 points map. And when we look at this line down here, we see that this was called F prime. That means this point that matches it is our original point, F. This one's called C prime, which means this is our original point, C. Okay? Quickly look at this last part right here, this line segment. It matches this one down here. And please fill in the missing numbers or letters based on what you understand about vectors and translations. Give you about 10 seconds here. All right, so one thing I know is that if this is E, then this point is E prime. And if this one says D prime, then that means that this one right here is D. The other thing I want you to notice is that this line is 5 centimeters. If we're just sliding it, our length stays the exact same. If we're just doing a translation, so that is 5 centimeters. We can fill all of that in. So a few things I want you to notice based on this is that lines are taken to lines. That means that it preserves the length. Angles are taken to angles. And that means they preserve the degree, right? We had the same degree here. We had the same length here. Okay? And yeah, that's pretty much what we wanted to get out of this exercise. Let's go ahead and move on to the next one. All right, exercise 3. It says translate the plane containing figure A along vector AB. Use your transparency to sketch the image of figure A by this translation, and then mark points on figure A, and then label the image of figure A accordingly. So you don't have transparency, and it's very hard to do this with just like our technology and not having actual paper. You could put a paper on top of this and trace it and then move it if you wanted to do that, but I'm not going to make you do that today, okay? So the first thing I want you to do is name this point. Let's just call this C. Let's call this one D, E, F, all the way around, G, H, I, J, K, there's a lot of points, M, N, and O. So there are a lot of points on this figure, and we're going to be translating it. We're going to be moving it this much and at this exact angle. And so this one is going to be probably right about here, my new point. And we're going to call this point C prime. Okay? And you're just going to go around and do this to all of the points. And you can just do it with me. This one. Actually, that's too much. This one is going to be right about here. And then we have one right about here. Here. It's not going to be perfect. We can try our best. Okay, and make sure we name them as we go and connect them. I think I skipped a letter, but you get the picture here. And obviously my star did not end up looking perfect, but it was just to show that you can, map it, map each point, name each point, and then name each image of the point, which again you denote with the prime symbol. Okay, once you have your star down, hopefully yours looks better than mine, you can move on. All right, we are done with this lesson. Let's summarize. It says translation occurs along a given vector. Just to remind you, a vector is a line segment, and it tells you what direction, to go, using a start point, or we call that an initial point, and an end point. And it gives you like a little arrow to show you which direction you are sliding, or which direction you are translating. The length of the vector tells you how long to slide. And so you'll see with these vectors down below, this is vector AB. We just denote that with AB with the arrow. This one's BA because we're starting at B and going to A. Okay. A translation is basically a rigid motion, and it's a slide. So it maps lines to lines, rays to rays, segments to segments, and angles to angles. It preserves your lengths and it preserves your measurements of angles. Okay, let's go ahead and move into your exit ticket and lesson reflection. And then today is Friday, so please make sure you have checked off your weekly checklist and submitted that, finished your MobyMax for the week, and completed the optional extra credit for Prodigy if you wish to do that. Alright, here's what your exit ticket looks like. It'll look a little bit different once it's in Galileo because it'll have some multiple choice options. Make sure you get this done and then move into your reflection and all that like I said before. Okay?